Welcome to the second video of chapter 5, where we're going to start talking about how bones develop and how bones actually change over time in terms of their shape and thickness as they restructure themselves depending on forces that are applied to the bones. And we'll also look at how bones can repair themselves whenever they're broken, and kind of how that process happens. So early on, after fertilization, when an embryo is developing and growing into a fetus, you have kind of the early structural forms of that embryo developing. And instead of starting out as a fully developed, skeletal system, we our skeletal system starts out as basically cartilaginous models. So we basically have cartilage models that are forming the skeletal system. And these cartilaginous structures are formed by chondroblasts. Okay. And so remember, we said blasts are kind of the forming cells. So chondro is cartilage, right? So this is cartilage forming cells. And then osteoblasts, right? So this is bone forming cells, will come in after those cartilaginous models are formed, and then they'll replace the cartilage with bone. And so that happens much later in fetal development. And then during childhood, you get primary and secondary ossification sites to form in those bones. And then as the individual grows and develops, the bones will then form what's known as growth plates, which are at the ends of the bones. And you basically get kind of this area where um, osteoblasts will continually replace cartilage that's formed from chondroblasts, and it leads to kind of this elongation of those bones. And so that happens during adolescence. And I've got a figure that will kind of help explain this elongation at growth plates a little bit better, in case you're still kind of confused on how that happens. Okay. But we're going to go through this in a little more detail over the next couple slides. All right, so in pre-adolescence, whenever your skeletal system is forming, you have this growth hormone that's basically stimulating the bones to lengthen. Whenever you are in your early adolescence, your estrogen and testosterone hormones will continue to stimulate that bone lengthening. And then in late adolescence, so same hormones will cause these cartilage growth plates to be replaced with bone. Okay? And so you have, different kind of growth patterns depending on what stage the individual is in the development of the skeletal system. Early on, more cartilaginous based structures, cartilaginous models, especially in the fetus. And then as you get older, most of the bones have ossified and the cartilage has been replaced. And there's only a small area in the region of those growth plates that has cartilage that is being replaced with bone. Okay? And so this figure kind of shows that process. So early on in the fetus, say the first 2 months of development, you have just a cartilaginous model of, say, for example, a long bone. And that cartilage will have osteoblasts to come in later on in the fetal development and start to replace that cartilage with bone, which you can see here. And you also can see that this bone now has a blood supply that is transporting those osteoblasts into the particular area where they're going to start making bone from the periosteum. And remember that periosteum is that thin cartilaginous layer that is on the outside of the bone structure. Now, in childhood, more and more of that cartilaginous model has been replaced with osteocytes. So those osteoblasts have replaced the cartilage with mature osteocytes, so mature bone cells. And these osteoblasts do that by secreting what's called an osteoid and just specific enzymes. You don't have to remember those. But what that does is it causes the deposition of hard hydroxyapatite, which is leading to the development of that hard, compact bone structure. Okay? But still in early childhood, the bones are still kind of the ends. A lot of that is still cartilaginous. It's not until you get into late adolescence that most of the bone structure itself has ossified. What's left is this growth plate, right? So this is that cartilaginous growth plate here. So this area here. And what happens is the growth goes outward towards the ends. And the way this works and leads to elongation is you will have osteoblasts on the bottom portion that lead to the conversion of the cartilage into bone, right? And then on the top area of the growth plate, you'll have chondroblasts that are depositing new cartilage on that upper surface. And so that kind of migrates the growth plate upwards, right? And so what we're going to do is we're going to zoom into this area in this next figure, and that's when we're going to try to articulate how this happens, right? So let's zoom into this growth plate over here. And so basically what happens is on the bottom of that growth plate, this blue area where this cartilage is at, osteoblasts will convert this cartilage into bone. Right? So this is now bone. And then up on the upper portion of that growth plate, right, new cartilage will be put down, right? And it will kind of move that growth plate upwards, right? So let's say this bottom portion becomes bone, that top portion is now cartilage. And then what happens is over time, that will continue to happen. So new chondroblasts will add to the top, right? More bone will be added to the bottom, right? And then you do that again, adds to the bottom, right? More chondroblasts adding cartilage to the top, right? And you can see how the bone will lengthen, right? Because it's continually adding bone, and then that growth plate kind of walks its way upwards, right? And then eventually, as you become an adult and your bones start growing, this will ossify itself. Okay. We have an animation kind of going through these different parts. So hopefully, if you have any questions, this animation will clear them up for you.
The process of bone formation begins with fetal development between 2 to 9 months and continues through childhood. Beginning at 2 months of fetal development, the first step involves the formation of a cartilaginous model of the future bone. The next step involves the formation of a collar by the osteoblasts, bone cells, at about 3 months of fetal development. Towards the end of fetal development, around 9 months, the shaft of the cartilage begins to hollow out, blood vessels infiltrate, and spongy bone tissue fills in and expands the region of bone growth. At birth, secondary centers of bone formation develop at the 2 ends of the bone. Bone development continues through childhood, with the central shaft becoming compacted and the spongy tissue forming at the ends. The cartilage remains only at the extremities, in the contact areas with adjacent bones, and in the cartilage growth plates.
Okay. So what we're going to look at now is how um, bones can remodel and repair themselves. So once bones have matured, so once they've finished that growth and development process that we just looked at, the bones can actually remodel and change shape depending on a bunch of different kind of life history strategies that we're doing as individuals. Okay, so our bones will remodel and reshape themselves based off of our diets, based off of our age, and exercise. So what forces we're constantly applying to our bones. So for example, weight-bearing exercises can increase bone mass by causing forces to be applied on the bones that causes bone to be added so that those forces are evenly applied over the entire structure of the bone itself, causing the mass of the bone to increase. And we've got an image of that kind of process where we'll show how that happened. And so what we end up with is just this homeostasis of the bones themselves, which is depending on the activity of osteoblasts. And so remember, this is the bone forming cells and the osteoclast. And the osteoclast is kind of the cells that break down the bones. Okay. And so the balance between bone forming and bone removal determines kind of the steady state or the shape and structure of the bones themselves. Now, you've probably heard of osteoporosis. Osteoporosis is just where it's a condition where you lose bone mass due to an imbalance of these two cell types, so osteoblast and osteoclast activity. And typically your osteoclasts are breaking down bone, causing them to be brittle and to not have as much bone mass, which causes them to break relatively easy. And so, like we mentioned, the bones can change shape, size, and also strength depending on a lot of those life history factors. Right? So, what type of exercise, diet, etc., that a person or an individual is doing. And specifically, when we look at exercises, you can have forces that are being put on a bone, and that stress or force actually causes electrical currents to move through the bones themselves. And those electrical currents stimulate the activity of osteoblasts. So basically, new bone development. So the areas where those electrical currents occur, you'll get new bone being deposited. And so if you have a lot of compressive stress, you have a lot of electrical currents, which means that you get bone added in those areas. Then areas where there's low compressive stress, you're not getting a lot of electrical currents. So you're not having that stimulated osteoblast activity. And so you'll get bone mass being reabsorbed in the areas where there's little compressive stress. And so we can use this, for example, via weight-bearing exercise to increase our overall mass and strength in our bones. And so let's say, for example, we have this bone, right, and we have this particular shape. Notice how it's slightly curved here, right? And let's say we apply a compressive force in this downward motion, okay? And so that compressive force is being applied straight down on this bone. Now imagine with this little bend, if you get a compressive force that's strong enough, it probably would push this bend outward and cause that to break. So you have more force on the inside of this bone compared to the outside due to this compressive force. So what that does is it stimulates osteoblast activity on the outside and stimulates osteoclast activity on the outside where bone will be removed. So you end up with this scenario in the middle where you have bone being added and then you have bone being removed due to the lack of compressive forces there. And so after that remodeling has happened, because of this compressive force, you now have a bone that is relatively straight that can deal with those compressive forces much better and is actually matched to those compressive forces because it's constantly exposed to that. And so that's kind of how weight bearing exercises increases the strength of our bones and just kind of converts, this kind of state here that could lead to a potential break to a stronger bone that can deal with those compressive forces. Now, the cells that are involved with the development and then the maintenance or the remodeling and restructuring of bones, we're going to mention here. And we've already talked about all of these. Just want to kind of get them and define them for you. So remember, anything that's chondro is cartilage. And so blast is forming, so cartilage forming cells. Osteoblast, right? So this is bone forming cells. Cytes are the mature bone cells, so or the cytes are mature cells, and since it's osteocytes, it's mature bone cells. And then clast is removal cells, and since it's osteoclast, these cells remove bone. Okay, so that's how you can kind of remember what each one of those cells do and what their functions are. Okay. And what regulates really the bone growth and formation and kind of the activity of those bone cells are what's known as PTH, which is a parathyroid hormone. So you get an increase in PTH whenever your blood calcium levels decrease. This basically tells the osteoclasts to secrete more bone dissolving enzymes. Another hormone is calcitonin, which is secreted whenever calcium levels are high. This basically says osteoblasts to add calcium to the bone. Okay, so whenever we have low calcium levels, we want calcium stores to be released into the blood. And so that's why you need more osteoclasts to dissolve that to release the calcium to the blood. Right? But whenever the calcium in the blood levels are high, you want to store that excess calcium. And so the way the body does that is it says, okay, we need osteoblasts to add this calcium to our bones and to store that so that we can use it later if our calcium levels drop. Okay? So PTH increases when you have low calcium levels. Calcitonin increases when you have high calcium levels. And then high calcium leads to increased osteoblasts. Low calcium leads to increased osteoclast. Okay. Now, bones can become damaged and often do. And so let's say you have a bone fracture, and what happens with that fracture is at that break site, at the fracture site, you get the formation of a hematoma. And in that area, you'll have fibroblasts. So remember, those are these cells that migrate to the area of that fracture and they start that repair process. What ends up happening is you'll get this formation of fibrocartilage, and it's a callus, and so it's basically like of the fibrocartilage is kind of like wrapping around that break site. And that fibrocartilage is made by chondroblasts, so those cartilaginous forming cells. Once that fibrocartilage callus is formed, you then have osteoclasts to come in and remove any damaged bone that is in the area that's dead, not functioning anymore, and just kind of needs to be removed. Once that happens, then osteoblasts will come in and they'll replace that cartilaginous callus with new bone in the area of that fracture. And the whole kind of time frame of this process, depending on the severity of the break and where that break is located, can take anywhere from a couple weeks to several months in order for the body to repair that fracture. Okay? And we have this process in an animation video for you.
The repair of bone tissue after damage involves the following steps: formation of blood clot, formation of fibrocartilaginous callus, formation of bony callus, and bone remodeling. Following a fracture of the bone, a blood clot or hematoma forms in the region of damage. Fibroblasts invade the area to form a cartilaginous callus. New blood vessels infiltrate the bone, and osteoblasts convert the cartilaginous callus into a bony callus. Formation of a bony callus helps in healing the fracture, in bone remodeling, and in restoring the bone to its original shape.
Okay. And so that's pretty much it for this second video on the skeletal system. So in this video, we talked about bone development, we talked about bone remodeling, and bone repair. In the third and final video for chapter 5, we're going to just go through and label and look at all of the different bones that are found in the skeletal system. And so we'll see you in the next video.